Welcome to the seventh part of thermal properties of matter. To study the change of state on heating or cooling, let us understand the following activity. Take some cubes of ice in a beaker and note the temperature, that will be 0 degrees Celsius. And now start heating it slowly on a constant heat source. And after every minute, note down the temperature by continuously stirring the mixture of water and ice. And draw a graph between temperature and time. You will observe no change in the temperature so long as there is ice in the beaker. The temperature of the system doesn't change even though heat is being continuously supplied, because this supplied heat is being utilized in changing the state of ice to liquid. This change of state from solid to liquid is called melting, and from liquid to solid is called fusion. It is observed that the temperature remains constant until the entire amount of solid substance melts. This is both the solid and liquid states of the substance coexist in thermal equilibrium during the change of states from solid to liquid. The temperature at which the solid and liquid states of substance are in thermal equilibrium with each other is called its melting point. And it is the characteristics of the substance which also depends on the pressure. And at standard atmospheric pressure, it is called normal melting point. To understand the process of melting of ice, take a slab of ice as shown in the diagram. Also, take a metallic wire and fix two blocks, say 5 kg each. Put the wire over the slab as shown, and you will observe that the wire passes through the ice slab. This happens due to the fact that just below the wire, ice melts at lower temperature due to increase in pressure. And when the wire has passed, water above the wire freezes again. Thus the wire passes through the slab and slab doesn't split. And this phenomena of refreezing is called reglation, means the phenomena in which the freezing point of water is lowered by the application of pressure. Practical applications of reglation. By pressing snow in our hand, we can transform it into a snowball. And when snow is pressed, its crystals melt. As the pressure is released, water refreezes, forming a snowball. When the wheels of cart pass over snow, ice melts due to increase in pressure exerted by the wheels. And when this pressure is released, water so formed refreezes on the wheels. That's why the wheels are covered with ice. Next example is of skating. Skating is possible due to the formation of water layer below the skates, as water is formed due to the increase of pressure and it acts as a lubricant. And the ice of a glacier pressed against the sides of its valley melts and in this way adapts itself to the shape of valley. After the whole of ice gets converted into water and as we continue further heating, you will observe that now the temperature begins to rise and it rises till it reaches nearly 100 degrees Celsius when it again becomes steady. The heat supplied is now being utilized to change water from liquid state to vapor or the gaseous state. And this change of state is called vaporization. And the temperature remains constant until the entire amount of liquid is converted into vapors. That is, both the liquid and vapor states of the substance coexist in thermal equilibrium during the change of state from liquid to vapor, and the temperature at which this exists is called its boiling point. To understand the process of boiling of water, take a round bottom flask, more than half filled with water. Keep it over a burner and fix a thermometer and steam outlet through the cork of the flask, as shown in the adjacent diagram. As water gets heated in the flask, first the air which was dissolved in the water will come out in the form of bubbles. And later on, bubbles of steam will form at the bottom, but as they rise to the cooler water near the top, they condense and disappear. Finally, as the temperature of entire mass of water reaches 100 degrees Celsius, bubbles of steam reach the surface and boiling is said to occur. The steam in the flask may not be visible, but as it comes out of the flask, it condenses as tiny droplets of water, giving a foggy appearance. If now the steam outlet is closed for a few seconds to increase the pressure in the flask, boiling stops. More heat would be required to raise the temperature, depending upon the increase in pressure before boiling begins again. Thus, boiling point increases with increase in pressure. Now remove the burner and allow water to cool at about 80 degrees Celsius. Remove the thermometer and the steam outlet and close the flask with the airtight cork. Keep the flask turned upside down on the stand. Pour ice cold water on the flask. Water vapors in the flask condense, reducing the pressure on the water surface inside the flask. And water begins to boil again. And now at a lower temperature. Thus you observe that the boiling point decreases with decrease in pressure. And this explains why cooking is difficult on hills. As on high altitudes, atmospheric pressure is lower and it will reduce the boiling point of water as compared to that at the sea level. On the other hand, boiling point is increased inside a pressure cooker by increasing the pressure, and hence cooking is faster. The boiling point of a substance at standard atmospheric pressure is called its normal boiling point. However, all substances do not pass through the three states solid, liquids, gas. There are certain substances which normally passes from solid to vapor state directly and vice versa. It is not necessary for every substance that the solid will be converted into liquid first. The change from solid state to vapor state without passing through the liquid state is called sublimation, and the substance is said to be sublime. Dry ice sublimes, so also iodine. And during the sublimation process, both the solid and vapor states of a substance coexist in thermal equilibrium.